We have an object composed of a steel hemisphere, a hollow copper cylinder, and an aluminum cone. The dimensions are as given. A force acts on this object, and we want to determine its acceleration, velocity, and position. To do this, we first need to calculate the mass of the object. This is done in the red, blue, and brown sections of the program. When you run the program, the mass consistently calculates to nearly 59 kilograms. In the program section on the right, the motion is then determined. You'll probably agree that there are quite a few blocks needed to calculate the mass of the object. Can't this be done more easily? Yes, it can, and for that, you need to write a script.
To write a MATLAB script, go to the MATLAB command window and open a new script. You can now type the commands into the script. These commands will clear the MATLAB memory and the command window. Next, enter the dimensions of the object, as well as the densities of steel, copper, and aluminum. When you click Run at the top, you'll first need to save the script. You will then see the entered data appear in the command window below. You can suppress the output to the command window by using semicolons. Next, enter the formulas for the masses of steel, copper, and aluminum. You'll see that the mass of steel matches what was previously calculated in the Simulink program itself. By adding the individual masses, we find the total mass of the object. By running the script again, we see that the mass calculated in the script is nearly 59 kilograms, which is the correct answer.
In the script, we've calculated the total mass, which is now stored in MATLAB's memory under the name mass total. Just to be sure everything's in place, we'll run the script again to ensure that mass total is securely saved. This means that the Simulink program will recognize this variable as well. We can now simply enter this variable name into the constant block representing the total mass. What about all those blocks in Simulink that were used to calculate the total mass? You can toss them out, they're no longer needed. When you run the Simulink program now, it seamlessly pulls the mass total variable from memory, and Simulink can use it just like any other value. The script effectively acts as a data provider. The beauty of using a script is that it handles all the algebraic calculations behind the scenes, saving you from cluttering your Simulink model with a bunch of blocks to achieve the same outcome. Meanwhile, Simulink can focus on what it does best, that is taking care of the double integration from acceleration to position.